Algorithms are step-by-step procedures or sets of rules used to solve a problem or perform a task. In essence, an algorithm is a finite sequence of well-defined instructions that leads to a desired outcome. They are foundational to computer science, but they also appear in many fields such as mathematics, engineering, biology, and even everyday activities, like following a recipe. Key characteristics of algorithms. 1. Finiteness. An algorithm must have a finite number of steps. 2. Well-defined. Each step in the algorithm must be clear and unambiguous. 3. Input. Algorithms typically have 0 or more inputs. 4. Output. They produce at least one output. 5. Effectiveness. The steps must be basic enough to be carried out, in principle, by a human or a machine. Introduction to algorithms in mathematics. In mathematics, algorithms provide methods for performing calculations, solving equations, finding roots, determining probabilities, or analyzing data sets. They are used to solve mathematical problems efficiently and accurately. For example, Euclidean algorithm, used to find the greatest common divisor, GCD, of two integers. Gauss-Jordan elimination, an algorithm to solve systems of linear equations. Fast Fourier transform, FFT, a method to compute the discrete Fourier transform efficiently. Concept of mathematics and algorithms. Mathematics underlies the design and analysis of algorithms. Mathematical concepts such as logic, number theory, combinatorics, and graph theory are often used to understand how algorithms work, their efficiency, and their correctness. Here's how they connect. 1. Logic and proofs. Used to prove that an algorithm will always produce the correct result, correctness. 2. Complexity theory. Uses mathematical tools to analyze the efficiency of algorithms in terms of time, how fast they run, and space, how much memory they use. 3. Probability and statistics. Algorithms often need to handle uncertainty or random events, such as in randomized algorithms or machine learning. Examples of algorithms. 1. Sorting algorithms like bubble sort, merge sort, quick sort arrange data in a particular order, ascending or descending. 2. Search algorithms like binary search find an element in a list or a database. 3. Optimization algorithms like linear programming find the best solution among many possibilities. 4. Graph algorithms like Dijkstra's algorithms solve problems related to graphs, such as finding the shortest path between nodes. Importance of algorithms. Algorithms are essential because they allow for efficient problem solving in computers and mathematics. They make it possible to handle large amounts of data, perform complex computations, and automate tasks in a wide range of applications, from web searches to scientific simulations.